So we are starting the new chapter. It is the system of particle and the center of mass, right? System of particles and center of mass, right? So first we will discuss system of particle and collision and the center of mass. First we will discuss the first topic of this chapter is the center of mass, right? Center of mass. Center of mass and the center of gravity, though both they are two things, right? So first of all we are discussing the center of mass. What is the center of mass? Can you anyone tell what is the center of mass? It is the point on the body. Definition I am writing. It is point on the body or outside the body. Outside the body, where all the mass of body is supposed to be concentrated, right? Concentrated. Is it clear or not? What does it mean? Suppose this is a rod, some symmetric body, for example, some symmetric bodies I am talking right about. If this is the rod, suppose, right? This is the rod of length L, mass M. Where the center of mass of this body is? In between this, right? If you consider a disc, this is the disc. The center of mass of this disc of mass M and radius R. So where the center of mass lies? In between this. Are you getting or not? This is the example 1, example 2. The example 3 you may take. Suppose this is the solid sphere, right? This is the solid sphere. Solid sphere, where is the center of mass? In the mid, right? So these are the points where, suppose the rectangular lamina, right? Suppose this is the rectangular lamina. This is the rectangular. So center of mass lies, right, in the mid for this symmetric body. As I told you, the center of mass is supposed to be the point on the body. So these are the center of mass lies on the body, but the center of mass may be outside the body. For example, this is the ring, right? It is the ring. And where the center of mass lies? At the center. So this point, which is the center of mass of the body, is not present on the body, right? So this is the center of mass. For example, hollow sphere. This is the solid sphere. The hollow sphere is like this, right? Suppose this is the hollow sphere. This is the center of mass. This center of mass is outside the body. So the definition of the center of mass is, it is a point on the body or outside the body where all the mass of the body is supposed to be concentrated. For example, human body, right? Human body. Our center of mass lies at the navel, right? Like this. Human body at navel. Understood or not? Copy this. So this is the center of mass of some bodies. So we will discuss first of all the center of mass in two parts, for the solid body and for point masses. So first I will explain the center of mass for the point masses, right? For example, now the first point you can write, center of mass for system of particle. Center of mass for system of particle, or for discrete point masses, right? For example, if we consider the space, and these are the point masses M1, M2 and M3. So the center of mass of the system will lie, right? If you join the system somewhere here, right, between this, it would be the center of mass. Are you getting or not? So if this is the M1, whose position vector is R1, this is the M3, position vector is R3, this is the M2, right, position vector is R2, and this is the center of mass, and its position vector is RCM. Are you getting or not? The position vector may be the coordinates of this R1 may be x1, y1, z1, right? x1, y1, z1, x2, y2, z2, right, x3, y3, z3. So for the center of mass also, for this RCM, the RCM vector will be equal to what? Say xCM I cap, yCM j cap, zCM k cap. It will be the position vector of the center of mass, where the center of mass, the x coordinate of the center of mass is given by m1 x1, m2 x2, and so on, divided by m1 plus m2 and so on, right? YCM in the similar way, you have to remember this formula. We are not going to derivation, we are not going to derive this formula, only just you have to remember m2 y2 and m1 plus m2. In the same way, the ZCM can also be written as the ZCM is equal to m1 z1 m2 z2 divided by m1 plus m2 and so on. Is it clear or not? Also, sometime the position vector r1, r2, r3 are given in the question. So the center of mass position vector may be given as m1, r1, m2, r2 and so on, divided by m1 plus m2 and so on. So this is the position vector of center of mass, right? From this equation or from this formula, the axiom YCM can be written in terms of R1. Listen one thing, sometime the R1 is given as x I cap, y x1 y1, j cap, z1 k cap. The R2 vector may be given as x2 I cap, y2 j cap, z2 k cap and so on. All right. Or sometime they will give just the coordinate, or they may write the position vector in terms of x, y, z coordinate of the point masses. Is it clear? Copy this. So this is the formula, right? And we can find the position vector of the center of mass. I'm giving an illustration. For example, if we have the equilateral triangle, suppose here the mass is 1 kg, the mass is 2 kg, right? And this mass is, suppose, the 4 kg it is, right? This is the M3. And the side of the equilateral triangle is, suppose, the 10 meter. You have to find the position vector of the center of mass. You have to find the RCM, or you may find the XCM or the YCM, right? Anything you can find. Is it clear or not? How to find this? Listen one thing. This is the M1. You must write the coordinate 0, 0. Its coordinate is, if this is 10, 10, 0. Are you getting or not? Can you tell me what is the coordinate of M3? Yes. This is the x coordinate, just half, the 5 meter in the x direction, and this is the y. This is the 60 degree, and the sine 60 we can write equal to y upon, sine 60 is y upon 10, right? So this is equal to root 3 by 2. So the y, it is 5, and y is equal to 5 root 3. So the coordinate are 5, 5 root 3. Is it clear or not? So if we assume this is the M1, so this is x1 y1, this is x2 y2, this is x3 y3. Is it clear or not? So the axiom can be written as m1 x1, m2 x2 plus m3 x3 divided by m1 plus m2 plus m3, right? So this is the m1 is equal to 1. What is the x1? 0. m2 is 2, it is 2. What is the x2? It is 10. The m3 is 4 into the x3. The x3 is 5 divided by 1 plus 2 plus 4. Is it clear? So 20 plus 20 divided by 7. It is 40 upon 7 meter is the axiom. So this is the axiom. In the same way, you can find the YCM, right? You have any doubt in solving this? Please tell. No, right? Very good. Copy this. The YCM, I am also calculating the YCM. the YCM is 1 into 0, 2 into 0, 4 into 5 root 3 divided by 1 plus 2 plus 4. So it is 7 and it is 20 root 3. Right? That is the answer. So this is the YCM, right, in the meter. Right? M1 Y1, M2 Y2, M3 Y3. Any doubt here you can ask? Right? Okay. So this is the center of mass. They in the space they will give some point masses and the coordinates, and you have to find the center of mass. You can do, right? The 2-point mass system. The important thing is the important point is 2-point mass, right? 2-point mass system. 2-point mass system. For example, if this is M1, right? This is M2, and the separation between them is L. So you have to find the right example. You have to find position of center of mass from M1. From M1 mean from here you have to find the center of mass. If the separation between them is L, can you tell anyone if this is M1, this is M2, where will be the center of mass between these 2 points? Can you tell me what is the position? Suppose this is R1, right? This is R1. Wait for 1 minute. To find the position of the center of mass from M1, either they may ask from M2. What will you do? You will arrange this system of particle on the x-axis, suppose, and the separation between them is L. So its coordinate will be 0, 0. Its coordinate comma will be L, 0. You understand or not? Right? So the center of mass will be over here, right? Somewhere between these 2-point masses. Not possible that center of mass is away from the line joining. The center of mass will always lie on the line joining the 2-point masses, right? Okay, it is not out of this system. So if this is the center of mass, so axiom will be what? Some value, and the YCM will be 0, right? So the axiom, I'm writing the axiom is equal to M1 into 0, M2 into L divided by M1 plus M2. So M2 upon M1 plus M2 into L, it will be the axiom, right? So the same axiom value will be equal to the R1. Are you getting or not? So the R1 is the distance of the center of mass from M1 is equal to M2 upon M1 plus M2 into L. Is it clear or not? Now, if you want to find the distance of the center of mass from M2, suppose this is R2. So how to find the R2? Say L minus R1. L minus R1 mean M2 upon M1 plus M2 into L, right? If you take L common, M1 plus M2 minus M2 divided by M1 plus M2, it will cancel out. So what is the R2 then? So M1 upon M1 plus M2 into L. So you will remember this two formula, and they will be used, right, very much in the calculation, right, in the center of mass of 2-point mass system. How to remember? Listen, suppose this is the M1, suppose this is 10 kg, M2, this is suppose 20 kg, and the 60 meter is the distance between them, right? Now you have to find the position of center of mass. Listen one thing, from M1 this is the R1, from M2 this is the R2. Is it clear or not? In case of R1, the M2 will be in the numerator. Is it clear? In case of M2, the M1 will be in the numerator. M1 plus M2 into L. Is it clear or not? So R1 is equal to what? M2. It is 20 upon 10 plus 20 into 60. So how much is this? It is 40 meter. R1 is 40 meter. In the same way, the R2 is M1, 10 upon 10 plus 20 into 60. So this is 20 meter. Are you getting or not? So in this way, the R1, R2 distance you can write directly using this formula. And listen one more thing. If you divide R1 upon R2, that is this distance divided by this distance. So M2 upon M1 plus M2 into L divided by M1 upon M1 plus M2 into L. So it will be M2 upon M1, right? R1 upon R2 is equal to M2 upon M1, implies that M1 R1 is equal to M2 R2. This is also the very important relation between the 2-point mass system, where R1 is the distance of the center of mass from M1 and from M2 respectively. M1 R1 is equal to M2 R2. You have to remember, many times this relation will be used in case of the center of mass questions, right? Copy this. Okay, listen one thing. This is the question number 8, right? For example, there is a bodies. This is the solid bodies also, right? So this solid body can be considered. This is the length A. This is the A. The body is like this, right? And this is also equal to the 2A. This is also equal to the 2A. You have to find the position of center of mass with respect to origin. This is the very good thing. Listen, this complete body can be converted into the 3 bodies or the 2 bodies. For example, you may consider this is the one solid body whose center of mass is M, whose center of mass is present over here. The mass we can assume M. The mass of this body is also equal to the M, and the mass of this body is assumed to be the M. So how to find the center of mass of this body? This solid body can be replaced by the point masses placed at the center of mass. Is it clear or not? So how many point masses are assumed? Say 3 point masses. So you may write the coordinate. If this is A by 2 comma A by 2, right? This is A by 2, this is A by 2. What is this distance? Can you tell me the coordinate of this system? Yes, 3A by 2 comma A by 2. What is the coordinate of this system? A by 2 comma 3A by 2. So now you can write down the axiom and YCM. Axiom is, I am writing just the form code M into A by 2 plus M into 3A by 2 plus M into A by 2 divided by M plus M is equal to 3M. Is it clear or not? So in the numerator 2 to 2, this is 5MA by 2 upon 3M. So the answer will be 5 upon 6A. This is the axiom. In the same way, can you find the YCM? Right. Copy this. The YCM will be the same also, right? YCM is what? M into A by 2 plus M into A by 2 plus M into 3A by 2 divided by M plus M. It is 3M, right? So this is M, not M by 2, right? So this is 5MA by 2 divided by 3M will cancel out. So 5 by 6A. The YCM value is the same, right? To solve this question, suppose we have a wire. If this is the wire of length L, the mass can be supposed to over here. This is the wire of the mass M supposed to be over here, right? And this is the position. Listen one thing. Definitely the center of mass will be over there. By symmetry you can say. And this is the 60-degree angle. So we can assume this is the 30-degree and 30-degree. This is the symmetric body, and this rod can be replaced by the point mass M. You understand this or not? So can you write the coordinate of the x comma y, x1, y1? Yes. If this is the L, the length is L by 2. If this is x, so the cos 30 is equal to what? Say base upon hypotenuse, and the sin 30 is equal to, say this is y upon hypotenuse. Is it clear or not? So this is root 3 by 2 is equal to 2x upon L. So x is equal to root 3 upon 4L. and this is 1 by 2, 2y upon L, y is equal to L by 4. Is it clear or not? So, yes. So, what is the coordinate of this? The coordinate of this root 3 by 4 and this is 1 by 4L. In the same way, if you want to write the coordinate of this, so x coordinate will be the same, but y coordinate will be just negative. Is it clear or not? Copy this. So the axiom can be written as m1 x1 plus m2 x2 divided by m1 x1 plus m2 x2 divided by m1 plus m2. Right, the mass is m. What is the x? Say root 3 by 4L plus m. What is the x2? Root 3 by 4L upon m plus m. So what is the axiom? The axiom will be root 3 by 4 into L when you will calculate. Obviously, listen one thing. If this is the point mass m and m, right? So where will be the center of mass? The mass is same, the mass is same. The center of mass will lie between this. Are you getting or not? Although this is the calculation we are doing so long, but there was no need to do that. After this is the first time, that is why I am telling you. Otherwise, by symmetry only, this is my m, so this is the center of mass. This is the center of mass. This is L by root 2. So this distance is the position of the center of mass, right? If you try to find the YCM using the same formula, m1 y1 plus m2 y2 divided by m1 plus m2. So m into y, the y is L by 4 plus the m minus L by 4 divided by m plus m. It will cancel. So the YCM must be 0, right? It is mathematically coming, but without calculation we must know that the YCM will be the 0. Is it clear or not? Copy this. Yes. m1 x1 plus m2 x2 divided by this thing you are getting or not? So please calculate this correctly. It will come in the denominator, it is 2m. In the numerator, it is 2m into root 3 by 4 into l. 2m will cancel out. So root 3 by 4l. Is it clear or not? Wait for 1 minute. Okay, yes, I understood. The length is the total length is the L. So instead of L, you can take the L by 2 it is. Then I have taken the length is L, right? Are you getting? I have taken the length of this rod is L. That is why I have taken this L by 2. If you take the L by 4, right, the answer will be matching. Is it clear or not? Right. Understood why the answer is root 3 by 4L? Yes, this is no. The total wire length was L, right? It was L. When you will bend this wire, right? So the wire length is what? Say L by 2. So when you will take this L by 4, so the x coordinate will be what? L by 4 cos 30. So it is L by 4 root 3 by 2, right? Root 3. So L root 3 by 8 will be the x coordinate only, right? So if you take the root 3 by 4, right, then it is the answer. Otherwise, I have just taken the L length L. So for this system, suppose we have the disc, right, and we have a circular plate. The dimension is as shown in the figure. This is the D and this is the D, right? So its center of mass will be over here. So this is the M1 I can assume, right? Its center of mass is M2 over here. Is it clear or not? These are the plates at the circular disc are made of with the from same material. Are you getting or not? Same material, same sheet. What does it mean? The same sheet. Suppose this is the sheet, right? This is the sheet. The mass is distributed over the surface. Are you getting? So the same sheet is used at a rectangle, a square is cut, also then a disk is cut. So its surface mass density, that is the mass per unit area, is constant. So let the surface mass density is what? Sir, what is the surface mass density? Surface mass density is represented by sigma kilogram per meter square. What does it mean? For 1 meter square, the mass of the disk, mass of the surface is sigma kg. Are you getting or not? We will choose the surface mass density of the material by which this disk and the square plate is made of, right? It is sigma kilogram per meter square. Should I elaborate this? More explanation needed for this, right? So this is the sigma kilogram per meter square. Now I have to write the m1 and m2. What is the area? What is its area? A1. What is its area? A2. The d into d, it is d square. If this is the d, what is the radius? Say d by 2, say pi r square. And radius is d by 2 whole square. This is pi d square by 4 is the area. Is it clear or not? So what the m1 I will write? The m1 I will write sigma into area. Right? This is sigma kilogram per meter square. If we multiply by area, the mass you will get. The sigma into area is what? Say d square. So this is the mass m1. Right? What is the mass m2? Say sigma into its area. Say pi by 4 d square. Is it clear or not? So if I assume this quantity to be the m0, so the m2 will be equal to what? This is pi by 4 sigma d square, and sigma d square is assumed to be m0. So pi by 4 m0. So I can write the m1 and m2 like this for simplicity. Is it clear or not? Yes. So now the center of mass of the combination from the two plate from the center of the disk. From the center of the disk, they are asking the center of mass. Are you getting or not? So what to do then? Listen one thing. Now you can arrange this system of disk and the rectangular plate like this. Are you getting? This is x, this is y. Is it clear or not? This is m1, this is m2. What is the distance between them? Say d. Because this d by 2, d by 2. Are you getting? Although without using the formula, you can find the answer I have given you. Suppose this is the m1, this is the m2, the distance is d. And if you want to find the position of the center of mass from m2, so this is the r2. So what will you write? You tell. r2 will be written as, say, yes, m1 upon m1 plus m2 into d. So what is the m1? m0 divided by m0 plus pi by 4 m0 into d. It will cancel out. 4 upon 4 plus pi into d will be the distance of the m2 from the center of mass. And this is the only question they are asking. Although this is the easiest method I use, but here as of now you can use, listen, 0 comma 0, and this is d comma 0. Are you getting? So first you will find the axiom. I am writing here the axiom. What is the axiom? Say this is m0, this is m0 by 4 into pi by 4 m0. Is it clear or not? So axiom you have to write in the same way. The m0 into 0 plus pi by 4 m0 into distance d divided by m0 plus pi by 4 m0. Right? When you will simplify, you will get 4 upon pi m0 d upon m0 common 1 plus 4 upon pi. So you will get m0 will cancel out 4 upon 4. Yes, pi by 4 into d. So this is the axiom. Wait for 1 minute. M2 is what? This is pi into sigma into d. Any mistake in this explanation? Yes, yes, the same thing is there. The m naught into m naught into m naught in the mass is what? Pi by 4m. And what is the x coordinate? City. So this is the correct. So it is pi. It is pi by 4. Is it clear or not? Yes, yes. This is the pi by 4. So this is pi upon 4 plus pi into d is the axiom. Are you getting or not? Right? But this is the distance from here. But they are asking the distance from M2. So what will you do? You tell. Yes, yes. So the R2 is nothing but the d minus axiom. So I'm writing here. So R2 will be equal to d minus, what is axiom? Say pi upon pi by 4 into d. So when you will 4d plus pi d minus pi d upon 4 plus pi. So the same thing 4 upon 4 plus pi into d, you will get the correct answer. So although it is a long method, right, and it is shortcut, you may write both of this, and this is very important because it take the very fast, it give the very fast result, right? So you should adopt this, but very first time you are studying, so you should not the both method. The m1 m2 you have to find, then you have to use this formula, right? So the solid bodies also, the center of mass of the solid body can also be calculated using this, the point masses m1 m2 like this, right? Assuming the body is replaced by the point mass on placed on the center of mass, right? Okay, now I'm writing the center of mass of solid body, right? Solid bodies. Listen one thing. If the solid body you consider, this is the solid body, right? If you consider the solid body, this is the solid body, center of mass will be over here. So you will choose the dm mass, right? Dm mass, and its coordinate is x, y, z like this. So the axiom, ycm, zcm, the formula axiom is equal to x into dm divided by integration of dm. The ycm is equal to y into dm divided by dm integration, and zcm is equal to integration of z dm into dm, right? How does it come? I am giving you some idea. Axiom is what? Say m1 x1 m2 x2 divided by m1 plus m2. So these are the point masses, and this solid body can be considered made of very small. This is dm1, this is dm2, this is dm3, and the coordinate is x1 x2 x3. So when you will write the coordinate dm1 x1 dm2 x2, right, like this, dm1 plus dm2, is it clear or not? So it is the summation of dm, and this is the summation of dmx. Is it clear or not? Dmi, this is the summation of dmxi. So this summation is nothing but the integration x dm, integration dm, right? You may write this theory or not, but the formula for the axiom ycm for the solid body you must remember like this, right? So this is the integration, this is the summation. Summation is nothing but the integration. So in this form, this is the summation, right? This is the summation, this is the summation, this is the summation, is nothing but integration. In the same way, all the formula come. Copy this. Okay, so this is the center of formula for the center of mass body. For the solid body, we can apply this formula to find the center of mass some solid bodies. A very simple example I am taking. Suppose this is the rod. The rod is a solid body of length L and the mass m, right? Although we know the center of mass will be in mid of this rod. Is it clear or not? So how to find this center of mass? Suppose you place this rod on the x-axis, right? You just take the point mass, this is the at distance x, the distance is width is dx, the mass is dm. All right, the total length is L. Is it clear? So the axiom, I can write x into dm upon dm. This is the rod, uniform rod, uniform rod. Is it clear or not? Uniform rod. This is the uniform rod of mass m length L. So can you write the elemental mass dm in terms of the uniform rod of mass m and length L? So can you tell me what will be the elemental mass dm of this elemental portion dx from origin at distance x? Can you tell what is the dm value? Yes, yes, yes. Listen, how to calculate this? Listen, if you consider the length L, for the length L, the mass is what? M. For 1 meter, the mass is m by L. This m by L is nothing but linear mass density. Linear mass density we call this, right? And sometimes it is represented by lambda m by L. And for this mass, for this rod, the linear mass density is constant. What does it mean? Suppose this is the rod. The rod is made of uniform mass density, the linear mass density. Do you understand or not? Uniform, right? So it is m by L. So L, length, the mass is m. 1 meter, mass is m by L. So for what is the mass for 2 meter? Can you tell? For 1 meter m by L, for 2 meter is what? Say 2m by L. For 3 meter, what is the mass? 3m by L. So for dx meter, what is the mass? Say m by L into dx. This is the dm mass m by L into dx. Is it clear or not? So by unitary method, we can write this elemental mass. So the axiom is nothing but x into dm, m by L into dx. This is m by L into dx. Although the m by L will come out from the integration, it will cancel out. So x into dm divided by x into dx into dx. Is it clear or not? Now you have to integrate. Listen, these point masses are spreading from x is equal to 0. They will start from x is equal to 0. This is the point mass, this is the point mass, this is the point mass, this is the point mass. So you have to all the point masses started from x is equal to 0. You have to add up to L. So 0 to L, 0 to L is the limit. What is the integration? X square by 2 from 0 to L. This is x from 0 to L. So this, put the upper limit, then lower limit. Put upper limit, lower limit. So L square upon 2L is equal to L by 2. Although we know this axiom is L by 2. And what is the YCM? Say 0. So although we know this, but we have found using the formula the center of mass of the rod, right? It is center of mass of rod of length L mass M. Is it clear or not? Copy this. Yes, yes. At the distance from the same end. Listen one thing. So this is the uniform rod, but the linear mass density is nothing but mass by L, right? Mass by L, which is constant for this rod, but for this rod, the linear mass density, right, whose mass per unit length, although generally we represent the linear mass density by lambda, surface mass density by sigma, and the volume mass density by rho. But in this question, it is written as rho, but I am still writing the linear mass density is represented by lambda kx square by L. Do you understand or not? This is the kg per meter. Do you understand or not? Listen, it is the constant over here, but here it is increasing. For example, listen, if the rod is of linear mass density similar, center of mass will be in the mid or not? Yes, it will be mid. But due to some reason, if the mass of the rod is increasing continuously, linear mass density increasing, suppose the rod of length L, is it clear or not? So the center of mass will be mid or somewhere else. Where the center of mass will be? On the heavier side. Is it clear or not? So that thing we have to find. So although the YCM will be 0, only the axiom will be there. So to find this center of mass, you will assume at distance x of elemental path of width dx, the mass is dm. So what is the axiom? Say x into dm into dm. Is it clear or not? You tell. Right. Now the dm we have to write. The dm is nothing but lambda into dx. You must remember this. Dm is nothing but, this is the linear mass density, lambda into dx. Lambda is in what? Kg per meter into meter. So dm mass will come. So what is the linear mass density? Linear mass density is nothing but the mass per unit length or mass per unit length, like this, right? But if you consider the dm, the dl, right, this is the dx. So what is the dm? Is equal to lambda kx square upon l into dx. Should I explain this once again if you don't understand this thing? Right, very good. X into dm, the value of dm is kx square upon l into dx upon kx square upon l into dx. KL is the constant, they will come out from the integration, will be cancelled out. So x cube into dx and x square into dx. Now the value is, you have to put the limit. These parts start from x is equal to 0, then this is the another part, 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 this is the another part. You have to add from 0 to x is equal to l. Is it clear or not? So 0 to l, 0 to l is the limit. x4 upon 4 from 0 to l, and this is x cube upon 3 from 0 to l. So put the upper limit, lower limit, upper limit, lower limit. So this is 3 by 4 L is the center of mass position. I think it is clear, right? Any doubt you can ask. Copy this.